Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss Gauss's law in dielectric. Let's begin. First of all, what is Gauss's law? The Gauss law states that the electric flux through any closed surface is equal to 1 by epsilon naught times the charge enclosed by that of surface. If q amount of charge is enclosed within that of surface, then according to Gauss law, the electric flux through that of closed surface is equal to q divided by epsilon naught. That is the electric flux closed surface integration of E dot ds, where E naught is the electric field vector and ds is the surface area element. We know basics of Gauss law. Here we have to find out Gauss law in case of dielectric. Therefore, we use parallel plate capacitor with medium air or vacuum. Then by taking a dielectric within that of parallel plate capacitor to calculate the Gauss law. Here let we consider a parallel plate capacitor . Taking that parallel plate capacitor, here taking plus q, here taking minus q as positive charge, here negative charge. And the plate area be A area of plate of the capacitor. And the medium between these two capacitor, the medium between the two plates is air or vacuum. Let E naught be the uniform electric field between the plates of the capacitor. Here we have to choose the Gaussian surface. Let the Gaussian surface that one be the Gaussian surface named as P Q R S, Gaussian surface. Now the electric flux through that of Gaussian surface with vacuum as medium between the plates of the capacitor according to Gauss law can be calculated. So we can find out electric flux through the Gaussian surface with vacuum as medium between the plates of the capacitor. According to Gauss law, that is calculated as E naught dot ds closed surface integration, that is the electric flux, how much, the total charge enclosed to that of Gaussian surface, that is plus q, divided by epsilon naught. Okay. Here the electric field and surface area both are parallel. E vector and ds vector are parallel with each other. Therefore, E dot ds is equal to E ds cos 0, cos 0 is equal to 1. Therefore, we have E ds only. So, E naught as outside, closed surface integration over S ds is equal to q by epsilon naught. E ds cos 0 1. So, E naught to outside of that of integral, that is the closed surface integration over ds and the total surface area. Total surface area of that of parallel plate capacitor A is equal to q by epsilon naught. A, as we prefer, the area of the plate of the capacitor. Now, E naught is equal to q divided by A epsilon naught. Here we apply Gauss law between the plates of the capacitor when the medium is air or vacuum. Now, we introduce a dielectric material having the dielectric constant K between the plates of the capacitor. Let we take one plate, another plate, here positive charge, negative charge, and a dielectric slab is placed in between the parallel plates of the capacitor. This one is the dielectric. Here plus q minus q, by the process of polarization, that end negative charge developed, and that end positive charge developed. So, the net electric field inside that of dielectric will be E. E naught is the electric field produced due to the parallel plate capacitor, and EP is the electric field produced within that of dielectric due to the process of polarization. So, the net electric field E is equal to E naught minus E p and its direction this way. Here we prefer a Gaussian surface. Let a Gaussian surface is drawn like this. This one is the Gaussian surface. So the charge developed here be minus qy induced charge, here plus qy. Gaussian surface named as PQRS. That one be the Gaussian surface. Look here, since the dielectric slab is placed in between the parallel plate capacitors, the induced charges appear on the surface of that of dielectric, here negative charge, here positive charge. These induced charges produce their own electric field, that is known as EP, electric field due to that of polarization process, and which is opposes the external electric field E naught, and the net electric field within that of dielectric, let E. If Qi is the induced surface charge of that end plus Qi, that end minus Qi. So within that of Gaussian surface, the net charge will be how much? The net charge will be plus q minus qi. So the net charge here, net charge within the Gaussian surface is equal to q minus qy. Okay, net charge within that of Gaussian surface. Now we can apply Gauss law in case of dielectric slab present in between the parallel plates. Now applying Gauss law, now applying Gauss law to the dielectric present in between the parallel plate capacitors. So the electric flux, closed surface integration over E dot ds is equal to net charge q minus qy divided by epsilon naught. Here E dot ds surface area and electric field intensity, these two are parallel. Again E vector parallel to ds vector. So E ds cos 0 1 E to that of outside, closed surface integration ds is equal to q minus qy divided by epsilon naught, or surface area of the plate A, q minus qy divided by epsilon naught, or E is equal to q minus qy divided by A into epsilon naught, or E is equal to q divided by A into epsilon naught minus qy divided by A into epsilon naught. Again, according to the definition of dielectric, the dielectric constant K, dielectric constant K is equal to E naught by E. Therefore, E is equal to E naught by K. We just implement these values here. In place of E, that is E naught by K is equal to Q divided by A epsilon naught minus Qi divided by A epsilon naught. So, E naught by K, the value of E naught is equal to Q divided by A epsilon naught. The value of E naught is put here. We get Q divided by A epsilon naught K is equal to Q divided by A epsilon naught minus Qi divided by A epsilon naught. Taking A epsilon naught as common and cancelling to both sides, we have Q by K is equal to Q minus Qi. Therefore, Qi is equal to Q minus Q by K. So, here Q taking as common, that will be 1 minus 1 by K, or Qi is equal to Q whole into 1 minus 1 by K. Now, that value of Qi can be put here. So, we can easily get Gauss law in case of dielectrics. Therefore, closed curve integration over that of surface S E dot ds is equal to, that is Q by epsilon naught minus Qi divided by epsilon naught, Q by epsilon naught minus Qi divided by epsilon naught. Okay. Here Q by epsilon naught minus, in place of Qi I can substitute Q whole into 1 minus K. So, it will be Q divided by epsilon naught 1 minus 1 by K equal to Q by epsilon naught minus Q by epsilon naught plus Q by epsilon naught K. Q by epsilon naught cancel out. So, we have closed surface integration over S E dot ds is equal to Q divided by epsilon naught into K. Look that expression. That expression is known as Gauss law in dielectrics. Gauss law in dielectrics. Generally, Gauss law, when the medium is air or vacuum, we have Q divided by epsilon naught, but in case of any medium, that expression changes to epsilon naught into K, and that dielectric constant be the K. This one is the Gauss law in dielectrics. So, with the help of this video lecture, we understand Gauss law in dielectric. First, we take parallel plate capacitor having air as medium and getting that expression E naught is equal to Q divided by A epsilon naught. Then taking a dielectric slab within that of plate and applying Gauss law by taking a Gaussian surface, we get Qy, and putting the value of Qy under this equation, we get closed surface integration over E dot ds is equal to Q divided by epsilon naught into K, charge divided by its permittivity term, that is the permittivity of free space into dielectric constant. This is the Gauss law in case of dielectrics. So, with this useful and informative notes, let me wind up this session. Thank you.